SWBA, students will be able to define and identify trapezoids, isosceles trapezoids, and kites and find measures. That's what we're going to work on today. Okay, so hey, actually, real quick, one thing I wanted to do at the end of 6-4, was there's a little spot where it says graphic organizer, right? Okay, we're gonna fill this graphic organizer before we go on to 6.5. So there's this graphic organizer. So you had 6.4, flip it over, turn it over, and you have this graphic organizer. We want it to be sideways here.
There's just a blank sheet.
Yeah, and it says graphic organizer at the top, right? Okay, it's not the very back of it. Not the very back. Make sure. Okay, you're on the right spot. Okay, so our main broad shape we've been doing, four-sided figure. What's it called? Our biggest one, our broadest one. Even broader. Quadrilateral.
Four-sided void.
That's just a four-sided polygon.
I don't know what one is.
Okay, on this graphic organizer thing, I just want you to write it. So at the top of yours, I want you to write it. We're gonna kind of make it almost like a family tree here.
Like right under the
Yeah. Yep. So it's right under those words, graphic organizer, right? Quadrilateral. Now, what was our next most specific thing? Not the most specific, our next parallelogram. We learned about parallelogram. And we knew some things about this parallelogram. We knew that both pairs of opposite sides are congruent and parallel. Both pairs of opposite angles are consecutive angles. Consecutive angles are something, Henry. Both pairs of opposite angles are congruent. Okay? And we learned the diagonals do what? Bisect each other. Okay? That's what we learned about a parallelogram. And then we have different types of parallelograms. So we're going to go from here, we're going to branch off into two different types. What's one type we're going to branch off into? Rectangle, very good. A rectangle was a parallelogram with four congruent, not sides, four congruent angles. That was our big change from parallelogram to rectangle. It got more specific. It's still a parallelogram and it's still a quadrilateral, but now it specifically has to have four congruent angles that are all 90 degrees. And then in addition, we also learned something about the diagonals of the rectangle. What did we learn about the diagonals of a rectangle? They're congruent. So not only do they bisect each other, they're also congruent. And what was the other one that branched out of the parallelogram? Rhombus. And with a rhombus, it was a parallelogram with four congruent sides. Okay? So these are both parallelograms with four congruent somethings. The rectangle is four congruent angles. The rhombus is four congruent sides. And in addition to that, we also learned something about the diagonals. Not that they're congruent like we learned in the rectangle. Okay, so they bisect each other and each other's angles. And also they are what with each other? They are perpendicular. Okay, the diagonals are perpendicular. They make perpendicular.
That should be like a sign.
Okay. And then we had one other thing, and it was like the rhombus and the parallelogram. They were walking down the hallway, they were holding hands. Now they have a kid, and what is this kid?
And who makes babies?
It's
a square.
It's a square. Thank you, Noah.
Then the rectangle live. Miss Prom went to
Stop. Okay, the square is both a rectangle and a rhombus. So it's a parallelogram with four right angles, like the rectangle, and four congruent sides, like the rhombus. And so everything we knew, we didn't have anything new that's specific to the rectangle. It just combines everything we learned before it. So it combines all that we know with the rectangle and all that we know with the rhombus, and we combine that into our square. And everything we knew about those, we know there. Okay, all the traits were dominant. None of them were recessive. They all somehow came through. Don't ask me how that works. Okay. So this little family tree here. So is a rectangle a rhombus? No. When would the only time a rectangle be a rhombus? If it's also a square. The only time a rectangle would ever be a rhombus is if it's actually a square. Because then it's both. But otherwise, A rectangle is never a rhombus unless it's a square.
Unless the family trees are supposed to come back together.
Roll Tide.
It's not Alabama.
Have you ever seen whose is it?
Not
Oh my
Alabama.
god, it's like so messed up. It's Miss Nielsen showed us it in class. It's a family tree and it goes like down and then it like comes back together and then it goes down again and goes back together and comes down.
What's
It's
Alabama?
Okay.
Roll Tide.
Keep going. Trapezoid note card. Let's go to your trapezoid note card. Roll Tide.
Roll Tide.
Those are so funny. Oh, I saw.
It's
I saw
Alabama.
cheap one. Like the thing too shocking where it's like, you know, and I saw this one. I don't know if it was yesterday or 2 years ago. I had a bunch of people. It was like, you're not supposed to have offspring with your relatives. And it was like, and it was like Alabama people, and it showed like a Pikachu face, like the eyes were like all messed up. You're like, oh. And so I sent that to a bunch of friends, and I had the caption on it, Roll Tide.
I definitely would have.
No.
Okay. Oh, come on. We just made three
Definition of a trapezoid. Definition of a trapezoid. Oh, sorry. Excuse me. What else is it first? It's nothing else. A trapezoid is nothing else.
It's not special.
Where's the definition?
We're getting there.
Why is it say what is
I'm talking.
Yeah, I actually put it the wrong order. Good. Relationships to sides, blanks. There is no relationship. I honestly don't remember where the
Is it
definition
okay
is.
if
It could be
I
anything.
put all lengths are not?
This is the gamble. What?
Is it okay if I put all lengths are not?
Okay, no congruent lengths, okay. So, just no congruent lengths, there's no relationship. We don't know anything about the lengths of a trapezoid. Okay? What about the slopes?
One of
Say
the
that again.
both sides of, or both pairs of opposite sides.
Don't quite agree with that.
One
Let me get a
pair.
parallel. How many pairs? One pair of opposite sides are parallel. So that's what we know from the slopes. There's one pair of opposite sides that are parallel.
Why does it keep getting bigger? I don't understand. Why did you make the font bigger when you made?
One pair of opposite sides are parallel. So I want everyone to have that down. Remember, we can shorten that down. One, make it the letter or the number, excuse me. Parallel, make it the symbol.
Mr. Costly, you really should have like pulled a prank on Aubrey and like not done any jokes the entire class.
That would be a prank. That'd be a gift.
No, it would be like
That'd be
she
a
like
blessing,
freaked
man.
out.
And then do
She's
one
like,
at the very end, maybe.
Like a
Yeah,
horrible
she's
Just
one.
like-
make her think she made it through all of class.
yeah.
That'd be good. I don't know if I could hold myself.
Or you could wait till she first
It's
says.
called
I got an idea.
man.
You basically every time you take a dad joke, you just keep that for later at the end. You just do all the dad jokes right at the end.
What you could have done is
Take
it.
like, wait till she
When-
first
I
says
would
hi,
die. I'd walk out.
and then
Oh,
like, stack them up and everything.
oh,
Nice.
Relationships of angles. What do we know about this?
Trash.
Why is he getting? There's no relation.
He's
Call me
shy.
Ray.
Yeah.
There's
They
one
don't
pair
have
of
to be.
Whoa, Josie.
Two consecutive angles are
Okay. So there are two pairs of consecutive supplementary angles, right? There are two pairs of that. So two pairs of consecutive angles are supplementary. Now I want you to write in on here. You should have a little bit of dead space right above this part because of the relationships of angles. So we call these consecutive angles, these two pairs, we call them leg angles. We'll call them leg angles. And we'll talk about that more when we talk about the trapezoid a little bit more here in a minute. We call those leg angles. So we might have a trapezoid. We might have a trapezoid look like this. That's possible. Or this top and the bottom are parallel.
That's just irritating.
Okay.
Why is my new favorite shape?
That's like the shape of Mr. Cup.
Wait,
what?
Hey, so hey, listen up. So we call these two parallel sides. We'll get with this in the definition, but I need the definition to pop up. I thought we had it earlier. These two sides, the parallel sides, we'll call those bases. So parallel sides are called bases. You might want to put that next to these parallel sides. You might want to put down like, oh, these are bases. There should be a little bit of dead space there next to that relationship of angles. So put down that those are bases. So the parallel sides are bases. Now we call the non-parallel sides legs. This would be a leg, and this would be a leg. So a pair of leg angles would be two angles that touch the same leg. So like here, this angle 1 and this angle 2 would be a pair of leg angles. So those would be supplementary. And this angle here and this angle here would be a pair of leg angles 3 and 4, and those would be supplementary as well. Okay, questions on that?
Okay, so Josie said that's
I don't know, my
irritating.
leg's kind
And
of
that's
bent.
why, right after that, I said, it's like the shape of Mr. Castle. Like, the shape form of Mr. Castle. It should be irritating.
Wait,
So it was really
Oh, I
cool.
thought you were calling him fat for a second.
I thought she was calling me trapezoidal. I'm like, what's that even mean?
Yeah.
Like,
I'm a
Or
trapezoid.
pie. Hi, trapezoid.
That's it goes back to like where
Yeah.
in the opposite world. where-
Owen, why does your family tree look like a trapezoid?
Okay, here's our definition. Man, I knew I wanted it to come up sometime soon. I jumped the gun. Man, I jumped the gun on it. Okay, a definition: a quadrilateral with exactly one pair of parallel sides, and then I have the picture. Man, I knew I had this set up better.
Big zigzag,
Darn it.
man.
I jumped the gun on my drawing. I didn't even
What
need
is
to draw it.
Can I actually draw that real
That
shape
was
of you?
really
No.
funny.
Why not?
What's so funny?
I don't know.
It's funny because you got something wrong.
Man, darn it, I knew I had something in here. I was like wondering, like, where's that? There it is.
Where's some of that Alabama blood?
No, I told Owen his family tree looked like a trapezoid.
He said, oh, and why does your family tree look like a trapezoid?
Okay, hey, so make sure we get this definition down. A quadrilateral is exactly one pair of parallel sides. If it has two pairs, then what kind of shape would it be? Something different that we learned. Parallelogram. When it's exactly one pair, no more, no less, it's a trapezoid. Yep. Yes.
I have a question. Can we make the bootleg Hannah Montana like bang like our flag with this class?
No, we should make a flag.
I showed it to so many people.
I haven't saved you.
I do
I
too.
showed it to somebody. I haven't saved it.
Somebody sent it to you?
Can someone
I already have it.
people when I show
Watch
you
the
like
show.
What's that graphic?
Hey,
My mom was five.
hey, does everybody have this definition up here?
Yeah.
Listen up, listen up, listen up. Okay, so the parallel sides are the bases, the non-parallel side are legs. And so, like I said, this would be a pair of leg angles, so these would be, excuse me, I don't need arcs there. That'd be a pair of leg angles, like 1 and 2 here, so those would be supplementary, these two consecutive angles. And then 3 and 4, this pair of leg angles would be supplementary as well. But angle 1 would not be supplementary with angle 4, and 2 would not be supplementary with angle 3. So it's just two pairs of consecutive angles that we'll call leg angles. Okay. Should be.
Actually, I was probably.
Yeah, I didn't scream for 1 second.
Okay.
They're 4
Diagonals.
Nothing.
You know nothing.
Okay, can I assume my top is?
There are 3 concrete. Bang my head up again.
Please do.
Nice door frame.
You want
Good counting skills.
Deuce.
Okay, yep.
Hey, that's why you're in the honors class, okay? Hey, questions on the trapezoid note card.
I'll fulfill my dream of becoming
Okay,
a snail.
now we're going to our notes. There's an example of the notes we're going to do.
Aw.
Example 1. We're supposed to find X and Y here. What kind of shape do we have? How do we know it's a trapezoid?
There is
Because it's just
one
trapezoid.
pair of parallel sides.
exactly one pair of parallel sides. Very good, Riley. How can we go about finding angles here? Haley? No. Well, okay, yeah. Okay, so here, two parallel lines, my bad. Two parallel lines cut by a transversal. What kind of angles would these be? Same side, and so they should be, and are they anyway? Because this would be a pair of leg angles, so would they be supplementary? Yeah. Okay, and would these two also be supplementary? Yeah. And that's why they're supplementary, is because they are same side interior angles. That's what, yeah. But,
Aubrey's really proud of your mind.
thank you. This one?
Top one.
Okay. Hey, so I want you guys to solve for x to y, and you're done. Raise your hand if you have questions. Raise your hand.
Oh, I want to point something out. There should only be one set of arrows because there's only one parallel line.
Technically, yeah, it doesn't matter.
Okay, guys, make sure you're solving for x to y, and when you're done, raise your hand. Or if you have questions, raise your hand. Yeah.
Daniel, you can have to press like Howard. I also be a snail fight in my inner side. Oh God.
Gary was confused.
I'm sorry.
Yeah. He's in the shell.
I think I got an idea.
No.
It might be painful.
Where's the screwdriver?
No, just pick up one of your arms and then crawl out.
Collapse.
There you go. There you go.
Oh,
Boy, looking like your family tree.
I've never done anything like that.
I'm gonna give birth.
the birth canal is working. Awesome, I'll check.
I got Alan.
Tyler,
Okay,
I have been given birth to.
checking you guys. Okay, okay. We got.
I think I was the one to give last.
Josie, was I right or wrong?
You're right.
Oh,
Hey, voice off, don't touch people.
that was very few.
Got the answer?
Nope, that was very few seconds after.
Tyler.
Yeah.
Alright, guys. Okay. Hey, let's listen up here. Can somebody help me with setting this one up? Okay, Josie, what's one thing you can do?
You can do x plus 48 plus 65
Okay, attention up here, guys. X plus 48 plus 65 equals 180. This pair of leg angles right here, are supplementary. So we add on to 180. So from here, you get x is equal to what? 67. Very good. How would we solve for y? Adrian.
You take 103 plus y equals 180.
Very good.
And subtract 103.
And you get
77.
77. Very good.
Oh my God.
I lost my grip. I slipped
Okay,
my
well,
move.
no, that
Just
is
draw a person, and then it's like they're saying it.
I will never say that, so don't draw me.
Give him a little beard.
Give him a big nose.
They're smiling, so it can't be Noah.
Fair point.
Okay,
I always smile and laugh at someone's.
Let's go to our isosceles trapezoid note card.
Oh,
It's really cute.
he does.
He was laughing
I'm not really sure which one I have first, definition or what else is it, but we'll figure this out. Definition. A trapezoid with congruent legs.
Oh my gosh.
What if you were like, what's a trapezoid? Like, can you tell me what an isosceles trapezoid is? It's a trapezoid with two congruent. Well, what is a trapezoid?
Well, we already know that now.
But what if you didn't?
Well, then you'd go back to that part.
Flips the pie around.
Are you okay?
We
No,
don't
I
know
didn't.
things.
Yeah.
But I don't.
Bad offer.
Don't
I
be
think
tired.
that-
Don't be
Bad.
tired.
Hey, whoa. Are we good with this definition?
Yes.
Yeah.
All that.
It's a trapezoid, with congruent legs. So the two legs are going to be congruent here. So one pair of sides will be parallel. The other pair of opposite sides are going to be congruent. What else is an isosceles trapezoid? It's a trapezoid. Boom. I pushed those together.
Black stuff.
The lengths, one pair of opposite sides are congruent. And that's part of our definition, isn't it?
Yeah.
So hopefully that's no surprise to us after we see that definition. Hopefully you have that on your note card already. That one pair of opposite sides are congruent.
Is it kites? Like a kite?
Yes.
That's why they're called kites.
A kite is like a kite. Just like a trapezoid is like a trapezoid. The rectangle is like a rectangle.
Or
Like,
you
you
can
mean
use it square as well.
Hey,
Yeah. Like,
what do we know about the slopes? Yeah.
One pair are.
The one pair of opposite sides are parallel. What do we call those parallel sides here? Bases. Okay, one pair of opposite sides are parallel. Hopefully we knew that already. I don't know either. What do we know about the angles? Okay, so we still know the two pairs of consecutive angles are supplementary, just like from a trapezoid. What else do we know? Do we notice anything else on an isosceles trapezoid? We notice another two pairs of consecutive angles are congruent. They shouldn't be the same angles, they should be different than the consecutive ones. We'll talk about that. So two pairs of congruent base angles. So just like we had leg angles, two angles that touch the leg. So if we had the trapezoid here, in this case an isosceles trapezoid here, these legs are congruent. We had leg angles, a pair of leg angles where they both touch the same leg. We can also have base angles, where they both touch the same base. So here the base angles are congruent to each other. So each pair of base angles are congruent to each other. So the base angles on the top of this one are congruent, the base angles on the bottom angle are congruent, but not to each other. And the leg angles are still supplementary, just like a trapezoid was. So the difference here, is that the base angles are congruent in addition to what we had before supplementary. Cool beans. Okay.
Means my needs.
We good with this part? You got people writing still.
Yes, Jesus.
I can start crying. Right, you gonna cry?
I got spaghetti on Saturday. No, it was like actually sad. Not like teenage, like 2 kids dying sad. It was like actually sad.
Okay. So let's go to example 2 before we finish the snow card. Before we finish the snow card, we're going to example 2.
Really?
Yes.
Maybe.
Okay.
Luigi?
So, what kind of trapezoid do we have here?
Pick one.
Isosceles. How do we know it's isosceles?
Two sides are
The legs are congruent. The non-parallel sides, the legs are congruent. Now, what do we know about the 115 and the Z in an isosceles trapezoid? They'd be congruent. What do we call them? A pair of, okay? Pair of base angles. Because AB is a base. It's all about the base. So these would be a pair of base angles. So if this is 115, what's Z going to be? How could we find angle D?
Setting that
115 minus 180.
Okay, so 180 would equal 115 plus W plus 18. Because these two angles are supplementary because they're a pair of leg angles, and leg angles are supplementary. So this ends up being 57?
No, 47. Is it 47? Yep. The calculator says so.
You're going back to college, buddy.
W equals 47.
Because it's
Okay.
65 minus 10 would be 55.
You're going back to college.
47 is equal to W, thank you. Whoops. Okay, now what else do we need to find?
V.
How could we find V?
15.
Adding
115.
18 to W.
Okay. So there's a couple ways. We could add 18 to W and get 65. What's another way we could do it?
180. Subtract 115.
Okay, 180 and subtract 115, because these are supplementary over there as well. Okay. Questions on those? Okay, let's go back to our note card. Get those diagonals.
You're killing me, Smalls.
I have this on here. Let's go back. Let's put this on the note card instead. Okay. Did I skip that? Okay. Where did I put it? Oh. I ordered this really weirdly. Okay, I'm going to go back to how I want it to be instead. Diagonals are congruent, so let's go back to the note card. I need to reorder that. Cool.
Look at that.
Good
There's
for
no
you.
room.
Good.
You're good.
You're alright.
You can live.
No.
I mean, I did.
I'm right.
Okay.
I'm 5 years old.
So diagonals are congruent. And that's going to be a theorem for us actually, which is why it says this theorem on our notes. If the trapezoid has a pair of congruent base angles, it is an isosceles trapezoid. So if it has a pair of congruent base angles, we automatically know that's going to be an isosceles trapezoid. So then we would know that if these base angles were congruent, even one pair, then we automatically know that the legs are going to be congruent. Yes. Good talk. Thanks. I think so. I do have half pictures off. Okay. I mean, are you guys able to see if I do this?
Oh, yeah.
Yeah.
No, I'm legally blind.
I'm legally blind as well. Okay. You know the diagonals are congruent. A trapezoid is isosceles if and only if its diagonals are congruent. If and only if its diagonals are congruent, so that's the only time it happens. So if the diagonals are not congruent, it's not isosceles. If they are congruent, it automatically is isosceles.
Oh, yeah, in trapezoid.
Yes. So here, how would we work on finding x? How? I want you guys to think about it. Don't blurt. Don't blurt. I want you to think about how to find x here in example. I really should say example 3. Goodness gracious.
That's another mistake.
I know.
Wow.
Okay. Somebody raise your hand and tell me how we could solve for this, Faith. Sorry. Okay. Say that again, Faith. I'm gonna disagree with that because x plus 12, the whole diagonal. Actually, here it's just this part of the diagonal. So how do we get the whole diagonal?
X plus 12 plus 8.
X plus 12 plus 8. And now what's that gonna equal, Faith? What's x plus 12 plus 8 gonna equal? What's this whole diagonal gonna equal? 3x minus 4 plus 10. So you have to add up those parts there. A little bit tricky. Minus 4.
I didn't dance to that.
I didn't. Okay. So now we would look to combine like terms. X plus 20 is equal to 3x plus 6. Get all of our x's together, get our numbers together. 14 is equal to 2x. Divide by 2, and x is equal to 7. Subtract
Oh,
from
I
6
thought
from
I
7.
looked at
You can't be smart.
Isn't that E?
No, can't.
18.
Quick
I'm having a struggle bus
2 plus 2
today.
less 4 minus 1 less 3
math. That's not correct. It sounded sad when you said that.
totally is. 2 plus 2 that's 4 minus 1 less 3.
Yeah, but when he says it, it's like equal to
I still
the
think
entire
it's not
thing
over.
is equal to each other, so it's like
I had to work tonight.
That sucks. I have softball practice.
Okay, so next part, mid-segment of a triangle. Okay, do you guys remember doing this a little bit?
It cuts it.
Yeah, it was not fun.
Mid-segment is a triangle. So if D is a mid-segment of AB, if D is a mid-segment of AB, and E is a mid-segment of AC, what is the length of mid-segment DE? Do you guys remember how we found that?
No.
Isn't it the half of 30?
It's half of 38. So in this case, it would be 19. The mid-segment of a triangle is half of the parallel side. The side is parallel to that third side. Right? A little bit of review there. Because right below this, you see we have mid-segment of a trapezoid. Okay? So mid-segment theorem for trapezoids here. It's parallel to each base. So just like this mid-segment of a triangle is parallel to this third side in half its length, it's parallel to each of the bases. And its length is half the sum of the bases. So here we have two sides that's parallel to, so we have to add them and take half. On the triangle, we only had one side that's parallel to, so we just took half of that one side. But here, since the mid-segment has two sides parallel to, we have to add them and then take half. Now, for it to be the mid-segment, it has to be, it has to connect the two midpoints of the legs, just like it would for a triangle, connect the two mid-segments of those sides. In this case, the two mid-segments of the legs. That's why I chose congruent and congruent on those.
So if we were to add 18 and 48, then we would have to take half of that.
So here, a way you can think of it is base 1, which I'm going to abbreviate as B1, plus base 2, which I'm going to abbreviate as B2, divided by 2 is equal to the mid-segment. Yep.
Base 1 equals
So base 1 plus base 2 over 2 would be the mid-segment. You add up the bases. Yes.
Wow.
Did it?
But is the door
I also remember
even
Nicholas
shut all the way?
in a bathroom break.
That's what happens only when it's not shut all the way. If it's shut, it'll latch. Okay. Does anybody still need this? Okay. Moving on, right below this, we're going to try and use this. So here, on example 3, how do we set this one up to find x? We have this mid-segment here. Very good. So 18 plus 48 is going to be
66.
divided by 2 is
33.
yep, that'd be the length of the mid-segment. Questions on that one? I know that one was kind of quick. Any questions on it? Okay, so example 4 on the backside. Okay, example 4 on the backside. This one, can we set this one up quite the same way?
No.
What do we have to do a little bit differently? Does anybody have an idea of what we have to do, Jacob?
So you'd have to multiply 15 times 2.
Okay, so we can still set this one up in the same formula though, right? So we can still set up 22 plus x over 2 is equal to 15, right? And from there, that's how we would know that our first step would be to multiply by 2 on both sides to get rid of this 2 in the denominator. So you have 22 plus x is equal to 30. I'm going to hold up for a second there and make sure we all have that setup down. Okay, that setup is what's important here. I trust in our solving ability from there, but the setup is very important that we need to have. So we set this one up just like we did up here, except for instead of what's missing, Here we don't have the mid-segment missing, we have one of the bases missing. Doesn't matter whether we call it base 1 or base
Is there
2.
a trick?
No, not really.
There is.
I mean, you can just do some like mental math with it, but there's not
You
really a
just
trick.
look at it like.
Yeah, you can do some mental math with it, but it's not really a trick.
But it will
You're
happen.
doing the same math. You're just doing it. You're doing the same math. You're just doing it in your head, so it feels different. But it's really the same. I know what you're talking about, though. So how do we get x by itself? Subtract 22. Kaylee, head up, please.
That's why.
X
people
is
use
equal
the
to
lights off.
8. I'm gonna say we can't have the lights off. We're gonna have heads down.
No. Yeah, I sleep with the lights on sometimes.
Okay. Questions on that one? Once again, that setup's important there. So if we don't understand how we got the setup or why we did it in solving, we need to ask right now. Okay, let's go to our kite note card. Almost done with these. Woo! Woo! Let's go! Okay. What else is it? It's nothing else. It's just a kite.
It's unique.
Okay. It's nothing else. Hopefully you have this from our GeoGebra activity. Okay? It's nothing else. Relationships of sides. There are 2 pairs of consecutive sides that are congruent. 2 pairs of consecutive sides are congruent. You can shorten down consecutive to CONS. I guess that color is probably pretty hard to see. Two pairs of consecutive sides are congruent. What did we notice about slopes? Did we notice anything about any parallel sides? No. So we can just put no relationship. No parallel sides, no relationship, however you want to put that. It's fine by me. Okay, relationships of angles. What did we notice about those? Very good. Exactly right. One pair of opposite angles are congruent. Once again, we can shorten opposite to OPP. Angles to like that. Congruent to the symbol. All sorts of things we can shorten up here. Save room on a note card. Let's see what's right on that.
Haven't heard that one before.
It's true. Too bad. Okay. So our definition with the picture. Our definition with the picture. It's a quadrilateral that has 2 pairs of consecutive congruent sides, but opposite sides are not congruent. How I shortened this down when I wrote it, I just put a quad, QUAD, that has 2 pairs of consecutive, CONS, congruent to the symbol, sides, but OPP opposite sides are. And the way I did not congruent, you can just do this symbol. Just like not equal, you can do the congruent symbol, just do it not. So you can shorten that way down. I barely fit it on one line, but I was still able to with all these shortened down. That helped. And I have a picture up here, so it does kind of look like the toy, like a kite, right? Like you would see flying around. You know, not that you see them all the time, but it does look like a typical kite would. And here we have 2 pairs of consecutive congruent sides. These 2 with the 1 tick mark on the left, and 2 pairs of another pair of consecutive congruent sides on the right side. They're consecutive next to each other. But opposite sides are not congruent. They cannot be for a kite to be a kite. Because otherwise it would be a rhombus. So we don't want that. What's supplementary mean? Yeah, the sides don't have an angle measure, right? Okay. Questions on this definition, or does anybody see this definition up here? Okay. Okay. So, Talking about the angles real quick, take a little sidebar here. If you look at the notes, we have it on here. So we can know which angles are going to be congruent. The way we're going to figure that out and help us out is going to be the ones that are splitting the pairs of consecutive congruent sides. So like this angle splits these consecutive, the ones that are between the non-consecutive sides to me. It's going to be angles between the non-congruent sides. The angles between the non-congruent sides. So BC is not congruent to CD, so this is one of our congruent angles. AB is not congruent to AB, so that's our other congruent angle. Excuse me, I said that wrong at first. It's splitting the non-congruent sides. Our congruent angles split the non-congruent sides. They don't go between our congruent sides, they split our non-congruent sides. Josie?
Should we do diagonals?
Not yet. Good question. Congrats on that. Okay, so I know I said that wrong a couple times at first. I'm going to say it right one more time. The congruent angles split or separate those non-congruent sides. So we know where to put the congruent angles based upon our side lengths. Questions on that? Okay. We're going to get to the diagonals right after this. So first, what would AB be here? Heard it? 7. Very good. It would be 7 centimeters. Because this would be a consecutive side and it would have to be congruent here. What do we know about the measure of angle B and the measure of angle D? They're going to be congruent, right? How could we find them? Noah?
360 minus 105 minus.
That'd be 160.
Okay. How do you know 360, by the way?
Because a quadrilateral equals 360.
Very good. It's still a quadrilateral, so it still equals 360. So this would be 200. And then how do we get each of those?
Divide by 2.
Divide by 2. And so a measure of angle B is 100 degrees, and measure of angle D is also 100 degrees. Questions on those? Okay. If I need to slow down on that one and re-explain any of that, please let me know, because I gladly will. Oh, you're welcome. Chief Sarge. Okay. So, going on to the next slide. Under note card, we have the same drawing here. So the diagonals are perpendicular, and the ones connecting the congruent angles is bisected. The diagonal connecting the congruent angles is bisected. So two things. First, they're perpendicular. Second, the one connecting the congruent angles is bisected. When I did perpendicular, I just literally just put diagonals and I just put that symbol, and that was my first bullet. So that's okay. You do that. Okay. So here, what pair of angles would be congruent on this kite? A and C. Because A splits these non-congruent sides, and C also splits the non-congruent sides. Now, so which diagonal here would be bisected? AC would be bisected, so that means AO is congruent to OC. It's always going to be the diagonal connecting those congruent angles. So wherever the congruent angles are, it's going to be the diagonal connecting those. And you can draw that in on your drawing as well if you want, on your picture. Where it says kite angles, that picture we drew the angles on, you can draw that on there as well. To make sure that looks like this. Second picture on this page. We're going to talk briefly about how we would do the last one, but we won't actually finish the last one. That's okay. First of all, questions on this slide before we move on.
I'm ready.
Okay. Hi, ready. I'm Mr. Carlson. Nice to meet you. Okay. So here, what do you know about these diagonals? They're perpendicular. Okay? So, if we look at all of these, we're supposed to find the missing side length of the kite. How could we find x, y? What kind of, is this a triangle here that's formed? With these two blue lines and this x, y? What kind of triangle?
Right.
A right triangle. Right triangle, what's up? Hey, what do you know about these two legs of the right triangle?
So you can do the a squared plus b squared.
Okay, you can do Pythagorean theorem, but what do we know about these two legs? So what kind of right triangle is this? Isosceles, right? Or a 45, 90 triangle? Does anybody remember our shortcut to go from the leg to the hypotenuse?
No.
So it'd be 12 square root 2. You multiply to get to the bigger side, and so this would be 12 square root 2. Hey, what would y z be then? Same thing, because they're congruent. Now, how could we find wx? Pythagorean theorem, okay? So when the diagonals get formed, they make 4 different triangles in there, 4 right triangles in there. And if you didn't know, if you didn't remember 45, 90 triangle and recognize this isosceles right triangle, you could also do, you could also just do the Pythagorean theorem on that one. Now there is one don't do on this.
Do you want?
How about the whole thing?
Jada, jada, jada.
There is one.
Alright, I don't want to mess up the streak, but.
I don't know there's a way. There's a recycling bin up here, Evan.
That's a longer shot. So I don't know if I'll make it.
What the heck?
Happy face.
Owen, how much fruit snacks do you eat, my G? There's like 8 packages in here.
No, we're gonna do that back page. Don't rip the back page off. We're still gonna use that. We're gonna use it next class. Hey, speaking of, when is our next class? Thursday.
About half a week before.
Don't forget math test tomorrow morning. So bring your laptop. The don't do for this assignment
Oh, it's only one.
is
They're back.
number 24. Not as many as 25, but still pretty funny. I thought you said we're
We don't do it because it's not funny.
No.
Yes.
I said we're gonna do the last page of the notes still. We're gonna do that today.
All the
That's
things
right.
that don't turn up the last
Hey,
page.
heads up. Also, I have to leave for soccer as well. So we're gonna move over to Mr. Titus's room for soccer. Okay. Any of you guys that need to get set somewhere else, we can do that real quick, and then the rest of you will go over to Mr. Titus's room.
Hey, Mr. Fossil.
Yeah.
My